So the problem I have shown here on the screen, it is what I would call a swaybar type of problem. A swaybar is a part of a car that essentially stabilizes an axle of the car. It basically makes it to where if you're going around the corner with your car, if you didn't have one of these, the car would have a tendency to where the body would roll relative to the wheels. And when you put a device like this on your vehicle, it basically makes your two sides of your suspension deflect more in unison and a little bit less independently, and it keeps your car from wanting to roll so bad. So that's essentially the type of device this is. I solved a problem like this, and you may have already seen a video that I'd published where I solved a problem finding stresses in a little linkage like this, finding the amount of position change there was of a particular point for a body like this. So I've already kind of done all that work by hand, and what I'd like to do now is start a kind of two-part series where first I build an assembly like this in SolidWorks and build it with enough specificity to how the different connections work to where I can then do the next part of the problem, and that is to simulate it using the simulation capability of SolidWorks. So let's just note a few things before we get started here. First of all, I'm going to note that it's we want it to be 8 inches from where these bearings are right here. And by the way, these are spherically articulating bearings that we're going to need to kind of use that here in just a moment when we look at modeling some things so that we actually sort of replicate the behavior of bearings like that. And you might remember that we had little pictures that showed how those spherically articulating bearings might work. We also have a fulcrum right here, which essentially just allows it to sway about that pivot point at E. I mentioned a second ago, it's 8 inches from this axis out to where point C here is located. That's where we're going to kind of assume that all the contact is occurring between these parts. Then it's 7 inches up to the fulcrum here, and then another 5 inches over to point D. And we have a 20-pound force applied there. So that maybe, if we got all that sort of fresh in our mind, we can just hop over here to SolidWorks. And you might notice here I'm using SolidWorks 2018. And what we're going to start with is a part. So I'm going to hit New, and then I do want a new part. Okay. And so this screen pops up. What you generally do in SolidWorks is you first start with a sketch, or sometimes more than one sketch, and then use those sketches to build solids. And so that's what I'm going to do here. Is I'm going to go into Sketch, and I'm going to do a sketch on this top plane, and the technique I'm going to use to build this U-shaped piece is to sweep a cross-section through a path. And that's the first sketch I'm going to make here, is a path. Okay, so start a sketch. And actually, let me explain this too. I'm going to make a, first of all, I'm going to make a model not of the entire U-shaped piece, but only half of it, because it is symmetric. The way I'm going to make it, it's going to be symmetric across a center plane. And so I'm just going to make one half of it and then mirror it. Okay, so let me start with just a portion of this path that goes right here. I'm going to then put a second portion of the path that goes up here. Okay, so far so good, pretty easy. That path has sort of a a curved part where it was bent, where the rod was bent into this U-shaped piece. And I want for that path to remain tangent. And so I'm going to go up here and select Tangent Arc and basically kind of connect those points. Now, it might be kind of hard to see. This is not necessarily tangent at this point over here because I haven't specified it enough to say that it will be tangent. It starts out being tangent up here just because of the type of arc that I selected, But this down here at this point, it's not necessarily tangent yet. So I'm going to take it and specify that it must be tangent using these relations, these sketch relations. All right, the next thing I want to do is make sure that this leg over here on this side is the right length. And so I'm going to do that by putting a center line in here. Okay, actually I'm going to do this by doing two center lines. One center line is going to be over like that, and the other center line is going to be up like this. Okay, and right now I haven't specified the lengths of either of those. Let me actually do this, and I can take this point and merge it with this point using these sketch relations. All right, and so once those points are merged, I can go in here and add some dimensions just right on these center lines. So I can put like a dimension right here. I mentioned a second ago that I wanted to make half of this U-shaped piece. And you might remember from the picture, it was a total of 7 + 5 inches lengthwise from point C to point D. So I'm going to do half of that, which would be 6 inches. Okay, so I'm going to put 6 right here. All right, the other one's a little bit more tricky, because if you look at this, it is 8 inches from point B to point C, but in reality, we need for that member BC to be just a little bit longer so that it overlaps enough with my other piece. And so I'm going to have it be long enough to where it covers not only right to the sort of theoretical point C, but also overlaps by 1 radius of rod CED. Okay, which since its diameter is 3/8 of an inch, that means I want this side over here to be 8 plus half of 3/8, which would be 3/16. And so if you want to enter that, you can do 8 with a space and then 3/16, and it'll know what that means. Okay. Another dimension that we don't have, but that we can probably guess as to what a good value might be, is the radius of this little arc over here. Okay. And so I'm going to specify that here. I want it to be fairly tight. I don't want it to have to be too sweeping, because that way it'll help me get the bearings that I'm going to apply here closer to the theoretical point that would match what we did with our hand calculation. And so, but we do need it big enough to where it has enough room to do that sweep, okay? And so the minimum would be basically 1 radius of the cross section that I'm sweeping, which would be kind of the radius of that circle that I'd have to sweep to make this rod. And so I want it to basically be a little bit bigger than that. And so I'm going to put in here 3/8. Okay, and that'll be enough of a radius that I'll be able to bend the rod using that radius. Okay, and this actually becomes my starting point for the little U-shaped Swaybar piece. Once you have that set up, you can hit this button right here, and you know, that is one of the sketches that I will need to make half of this Swaybar. Before I go too much further here, I want to go ahead and save this. So we're going to save that part as, okay, now I'm going to go into my documents here, and I've made a little folder. Okay, so I want to save this in there, and let me save this as the actual Swaybar. So I'm just going to name it Swaybar. Okay. All right, now sometimes it's easier to visualize these things with another viewpoint, and so I'm going to go in here and set up a diametric view of this little sketch. As you might suspect, this is not enough of a sketch yet. We need to now add the cross section that we're going to sweep along that path. So I'm going to go in here and pick the front plane and then hit sketch, and on there I'm going to sketch the cross section that we are going to sweep along that path. Okay, it is just a circle, and so what I can do is just sketch that circle and then tell it how big to be. Okay, it says on this document here, it says that the diameter of that rod should be 1/2 inch, and so I'm going to set that at 0.5. Okay, and that's enough for that. We are now ready to go ahead and do a sweep of that cross section. All right, so I'm going to hit a little rebuild button and then go over to the features tab right here. One of the options you might see is swept boss base. So I'm going to take that, and it wants, in this first option right here, it wants me to pick the sketch. Okay, so I'll pick that little sketch right there. And then it says in my next one, it wants me to pick the path. And so I pick that path, and it makes this little portion of my Swaybar. Okay, and that's what I need for right now. All right, what do you think might be next? Well, we probably need to make a little carve out so that we can get the little tip of this. You know, they look a little bit like this. Let's actually do some more definition on that and make sure we get it a good real shape. Okay, a good plane probably to use to do that sketch is going to be this right plane, and so I'm going to do that and then start a sketch on that right plane. A tool I like to use in terms of visualization is this normal to. It gets my picture to where it's easy to sketch on because I'm normal to that surface now. Now what I'm going to do on this sketch is sketch relative to this point right here, a little line that goes up, okay, and then another line that goes across. Okay, and from there I'm going to also pick a tangent arc again, and relative to this point I'm going to bring it down a little ways. Let me also put in another little segment right here that goes down to that edge, and another segment along here that goes right to there. I'm going to take these 2 points, and with sketch relations I'm going to merge them. Okay, and you might notice this little point right here is the center of that arc. I'm going to specify that that center of that arc has to lie on this line. So I'm going to use these sketch relations so that that's coincident. And now what I've done is I've set this whole thing up to where it's going to generally be the right shape, and we just need to add a couple of dimensions so that we define how large it all is. So I'm going to add a dimension up here on the top. Okay, I need this dimension to be long enough to accommodate the width of the that rocker piece that is, I can think it was CED or something on that picture, right? This piece right here, CED. And I need it to be wide enough so that I can accommodate the diameter of that rod. Okay, so I need 3/8 of an inch, which is 0.375. Okay, I also want to give myself just a little bit of height relative to the center lines. I'm going to leave the center line sort of free on this thing. So let me choose some little amount of height that I apply right here. Okay, for my dimensions, I'm going to pick a little height right here, and I don't want it to be very tall because I want it to, you know, leave enough sort of meat of that little segment, this little segment that's going to exist up here. I want that to be thick enough to where we won't have stress problems up there. So I'm going to make this be 0.05 inches. Okay, and I believe that does a good job of defining that little shape of the cutout. Okay, so at this point I'm going to hit, yep, that's what I want for that dimension. I'm going to rebuild this sketch, and then I'm going to, under features, do an extruded cut. Okay, and I may not have had that sketch picked when I went to do my extruded cut. So now it's doing this cut extrude, and I'm going to pick a through all both directions, right? I basically want it to cut through this thing, and if you want to see, have a little preview of what it thinks it's about to do, we can go back to our diametric view. Okay, and it's going to do a cut basically through everything in both directions, which is fine. There's nothing else it's going to cut through on the other direction or anything like that. So I'm going to hit OK, and that'll leave a little slice on the end of the rod where I'm going to have the interaction happening between this piece and the rocker piece that it interfaces with. Okay, so what we need to do now is think very carefully about how exactly this piece is going to interface with the other piece. The way we modeled it in our problem that we did is more or less as a ball joint, right? We said no significant moments are going to be interacted between or reacted between this piece and the piece it interfaces with at CED. So the thing is, we can sort of have that in mind when we solve a problem like this by hand, but we have to be pretty specific about how we model that in SolidWorks in order for it to behave properly. And so what I'm going to do is go ahead and put a little spherical dimple in the little underside surface of this thing. Basically, right on this little face right here, I'm going to put a little spherical dimple in there so that it has a spot where it can do this, you know, sort of spherical articulation between those two parts. Okay, so let me pick that face right there. You know, technically I actually don't really, I guess I could do it on that face. I don't really want that face. Let me say it that way. What I'd rather do, I'd rather actually pick perhaps this right plane right here and do a sketch on that plane. Because what I can do there, let me do this normal to command here real quick. Okay, on this right plane, what I can do is, you know, actually first of all, what I probably want to do is, well, there's a bunch of ways we could do this. We could define a center line relative to this end and make it exactly 8 inches across, or if we trust ourselves with how long we made this thing in the first place, then it should be 1 radius worth of the rod CED back from the tip, right? Should be about 1 radius worth back from here. So that's how I'm actually going to do this, is with a center line that starts at this location and goes back by 1 radius of the member CED, and that radius is 3/16. Okay, so 3/16. All right, and that gives me a point where I can begin essentially like a little circular carve out, right? Or a part of a circle carve out, right? So I can basically take like a line that goes up something like this, and another line that goes across something like this. Okay, and there's another type of arc that we can do in here, and it's called a center point arc. It allows you to pick a center point and then go to another point like this and do a little arc. Let me zoom in a little bit. So the arc I just made starts at this center point, or the arc kind of starts at this point with this as a center point. And now the next thing we need to do is merge this point with this point. Okay, and let's set a dimension for this. Okay, it's not actually that important that we get anything, you know, too specified here. What I think might be a good diameter for this little kind of ball is going to be, you know, let's say the diameter should be maybe 1/4 of an inch, which means a radius, which is what I'm setting here, might be about 0.125 inches. Okay. Now, what this has set up is a sketch that I can do a revolved cut, right? And it'll cut out a little dimple in that face. Okay, if you want to kind of see what that's going to look like, I can, you know, rotate this around a little bit. It's going to cut a little dimple in this face. Okay, to get that, we go to Features and we go to Revolved Cut. All right, now it didn't pick a good axis sort of automatically in order to do this revolve, and so I need to go in here and say I do not want that selection. Instead, I'd rather have my axis of revolution be this line right here, and that way it'll do this little revolved cut. Okay, and what you see there is this little dimple that we've now added in there, and that's going to be where this interaction begins to occur. All right, probably worthwhile saving this thing. And let's get it back into an orientation that helps us be oriented with what we're dealing with. Okay, maybe something like that. All right, this isn't a U-shaped piece yet, right? This is, at this point, only one leg of it. What do we need to do to make a U-shaped piece? Well, we need to take this thing and mirror it across a face. Okay, so there's a little function up here you might see that's called mirror. If I pick that, it asks me for a face across which we are going to mirror this part. And I want to pick, this is a nice little trick, let me kind of make sure I don't blow by this. I want to pick a face that's obscured here by another face. I want to pick one that's back there. It's just, you know, it's kind of behind where my cursor is located, but it's not the first thing you see from our viewpoint here. I can still pick that face, and I can use a little technique called Select Other. Okay, and it gives you a number of different things you can try to pick, and it actually puts them in a menu over here. And you can see if I hover over this face on this sweep, it actually looks like it's highlighting the correct thing, right? And that's exactly what I need. The next thing I want to know is what features do I want to mirror? Well, I want to mirror everything, right? Everything I've created so far, I want to mirror. So I can go into this little design tree and pick all of these pieces, right? I can pick the sweep. If you hold your control key down, you can pick multiple things. So I can pick the cut extrude, that kind of made that little notch on the end, and then I can also pick the revolved cut that made the dimple. And once I have selected all of those things, if I hit check, now it has built that U-shaped piece. Okay, and I'll just sort of check it out real quick and make sure, yep, it's got a dimple on both ends, so we're doing good. All right. I have one last little step I want to do on this part, and the reason that I want to do this one last little step is because we're going to need it in the simulation phase. Might be kind of hard to see exactly how we're going to need it as we're doing it, but just, I guess, sort of trust me for right now. I'm going to go in here and on this face right here, okay, I'm going to put a sketch right here that's round. Okay, so I'm going to go in here and start a sketch. I'm going to put a circle on this sketch. Okay. I'm going to specify that I want that circle to be concentric with this circle. And what I'm going to use this circle for, just to kind of give you a little preview of what we're planning on doing, we're going to need to apply that 20-pound load to somewhere. And if we want to make it accurate, we want to put that 20-pound load on the top surface of this piece. Well, what I'm doing right now is I'm defining, I'm going to use this as a shape to project upward onto that top surface and define the little area where I'm going to be able to apply that 20-pound load. And so I'm going to specify the dimensions of the size of this circle. Okay. I'm going to specify that the size of that circle, I want it to be a little bit smaller probably than the size of the rod itself, right? So 1/2 inch would be the diameter of this rod. I want it to be a little bit smaller than that. So I don't know, maybe about 0.4. It doesn't really matter, as we'll see here in a few minutes. Let's actually take a look at that real quick. I don't actually really like that size either because I don't want it to overlap this other edge. Let me make it a little bit smaller. Okay, let me cut it down to about 0.3. That's fine. All right, and you know, that's all I really need for that sketch for right now. And I know it feels a little bit weird doing a sketch and then not using it right now for anything, but you'll see how we'll get to use it whenever we get ready to do the simulation part of this project. All right, so let me go back into this view again, the diametric view. We are now finished with this little part, so I'm going to save it. I'm going to start my next little piece that I need, and that would be the rocker piece that goes from one side to the other. Okay, so I'm going to go to New. I'm going to do a new part, and I'm going to build this other piece. So I'm going to start with this right plane, and that's basically, I'm going to just make a circle and extrude it out and build this rod. All right, so on that face, I'm going to start a sketch. I'm going to put a circle right at the origin. And then I'm going to size that circle appropriately for the size of this rod. Okay, it is a 3/8. All right, so far so good. That's basically all I need to do there. The next piece is to do an extruded boss base, kind of what they call it. The way I want to do this though is make it a mid-plane in here, right? If you do a mid-plane, it basically makes it to where when it extrudes, it leaves that origin right at the middle of the whole piece. All right, how long do I want to extrude that? Well, let me go back in here. I want it to be long enough so that my 12 inches covers center to center from C to D, but I want it a little bit longer than that because I want to go out to the ends, you know, out to kind of as far as the extent goes for rod AD like that and rod BC over here. That means I need essentially one radius on one end of rod AD and one radius on the other end of rod BC in order to extend that far, that in addition to the 12-inch center to center distance. Okay, and so that basically means one diameter. So I basically add a 1/2 inch onto the original length of this, so I need it to be 12.5 inches. All right, so I go into my SolidWorks and I turn this into 12.5. If you want to kind of check that out, this is what we're making. All right, it's a good start. What do we want to do next? Probably what we want to do next is make the little cutouts, kind of like we did before. You know what? What might actually be a better plan, just like I did on my other one, and I can change this really easily by going in here. Doing this one with a mirror actually makes a lot of sense as well. So let me go in here and change this from being a mid-plane, make it just a one direction. I'm going to change this to only half of the 12.5. So I'm going to do this at 6.25. Okay. There's some techniques like that you can do that helps you not have to do quite as much work. Okay, so on the right, or excuse me, on the front plane right here, I'm going to sketch the little cutout. Okay, and on that little plane right there, let's see, I want to go normal to right here. And I'm going to, let me do this, I'm going to start with a little line right there, And I also want a line relative to the center of this piece, right? So that little center right there up to that point. I'm going to do another line that goes down like this up to that point, and then another line that goes across over to here. Okay, and I'm not being real careful about the sizes, the relative sizes of anything or any of that stuff. At this point, I can do a tangent arc relative to this piece. Okay, and then by do this, I'm going to do my little cutout. I want it to join up with that point right there. And then this center point of that arc, I'm going to specify that it has to be coincident with that line. Okay, and at this point I have some freedom as to what shape this actually implies. I need to now take away that freedom by actually specifying the dimensions that I want. So right here, I want this to be the width of the rod that's interfacing with this. That rod was the segment BC right here. So, and it has a diameter of a 1/2 inch. So I want this to be 0.5. Just like I did a little bit of relief on the other side right here, I'm going to do that same thing now. Okay, I'm going to make that 0.05. And what else? Actually, I think that takes care of this piece. Once I've got those dimensions and that sketch all made nicely, what I want to do is another extruded cut. Okay, and I want to take a look and see what it actually looks like. So I'm going to go in here to the diametric view. All right, let me do a through all, both directions. Okay, and that's going to be the cut that I make. Okay, now the shape that I want to make on here is a little sort of protruding ball so that it can interface with the little dimple that I put in the other side. That's not hard to do. I can again pick the front plane right here, and I can set up another sketch. Let me go normal to that sketch. And what I want to do now is actually kind of the first step is I know how far I want this to be from the center of this rocker piece. And so let me start with that. Let me start with a center line that goes from this point right here. Okay, and I do want it to be horizontal, but I can specify exactly where it ends up with a dimension right here. Now this is actually going to specify that literal center of the ball where the interface happens between this part and the U-shaped piece. And so I want it to be right at 6 inches. I don't want this one to overlap at all. Okay, so I want 6 inches right there. And when you take a look at that, it puts a nice point right here that can become the center line of me building a little spherical ball. Essentially, it's going to sit right here. Okay, so toward that end, let me go ahead and I'm going to start with a line. This line is going to be, this end is going to be coincident with this. And then this point right here is going to be coincident with the line. Okay. And then I'm going to do another one of those center point arcs where I start here. Okay. Sometimes it does, when you do these arcs, it's like, that's not what I wanted, but it's nice, you go all the way around, it'll sometimes pick out the direction you did want. Okay. All right, so I'm just going to let that go a little bit like that. I also want to put a line from this point and have it be directed along this edge. And then I want to make that point merge with that point. Okay. And I only lack one thing at this point, and that's one dimension. The dimension I'm lacking is the size of this ball. Okay. So I am going to specify now the size of this ball, and I want it to be the same size as the socket, the dimple that I made on the other side that it's going to interface with. And you might remember that I made it a 1/4 inch diameter or 1/8 of an inch radius. Okay, that'll make a little cross section like this. And what I'm going to now do is take that cross section, tell you what, I'll give you a 3D view so you can see what we're about to do. Okay, I'm going to take that cross section and I'm going to revolve it around a line, one of its lines. Okay, so a revolved boss base. It probably didn't pick the correct line here at first, so I'm going to clear that, and instead I'm going to pick this as my axis around which it will build this shape. All right, so now that gives me that little ball shape. Tell you what I need to do at this point is save, because I don't want to lose all my work if it crashes. So let me just put this in here as rocker, since that's what I've been referring to it as. All right, one last thing I want to do in here before I leave, and that is anytime you have sharp edges like this, sharp internal edges, it's not good for getting good results, or sometimes it makes it even hard for it to even solve with simulations. I want to put a fillet on that basically takes care of, essentially the physical thing it's taking care of is stress concentrations. And so I want to get rid of that by putting a fillet right there. So if I hit fillet, I can now select this edge, okay, and 0.1 is probably too large. Let me go in here and say 0.02. Okay, and that puts a little rounded transition from the ball to the rest of the piece. All right, this is what we have made so far. I think our next piece, next step is to do a mirror, just like we did on the last one, and we want to mirror across this face over on this side. So if I go to mirror, it's wanting that mirror face. I can use my select other technique that I showed you a minute ago. I'm going to select that face, and now it wants to know the features that we want to mirror. So I go inside of here, and I want to basically do it all, right? The original piece there, the cut, the revolve, and the fillet. Okay, and now it has made this sort of rocker-shaped piece that has those little spherical ends that will actually do the mating, and hopefully those will act properly. You know, they'll act just how something real would act. Or I guess really what we're trying to do is match what we assumed whenever we did our hand calculation on a piece like this, and hopefully that'll give us our best chance of getting results that match up between our hand calculations and this piece. All right, so what we want to do next is there's a couple more pieces that I would like to build that will actually aid with the interfacing. So if you go in here, you might notice there was these little spherically shaped interfaces on these bearings, we can kind of simulate that. We don't need to get all the detail of the ball bearing and everything like that, but if we make a little piece that can interface with these pieces, we can get that spherical sort of articulation accurately represented in our simulation that we're about to do. All right, so here's how I recommend that we do that. Let me save this rocker, and I'll go into a new part. Okay, I'm going to build sort of a little bushing. Here's how I want to build that bushing. Let me do it this way. I guess I probably want this front plane. And I'm going to, on that front plane, start a sketch. And I'm going to put in a center line. Okay. And I want to make it pretty specific how I interface this center line. Okay, I'm going to select the midpoint. I'm going to say that midpoint is going to be right there on the origin. Okay. And then I'm going to put in kind of this line right here is going to be the surface, and it's going to end up being the surface that mates with that rod, the U-shaped rod. Okay, and I want to make it the proper diameter, so I'm going to put in a dimension here that goes from this line up to this line, and that's going to end up basically being the radius of the U-shaped piece. And since it had a 1/2 inch diameter, I want this radius to be 0.25. Okay, and that sets that distance right there. What I'm going to do next is I want to kind of define how big do I want this bushing to be. Let me put in another center line that goes from the origin up like this. Okay, and that's what's going to define the kind of the outer size of this part. So let me put in, I don't know, maybe 1 inch diameter is big enough. So let me put in 0.5. Okay, and I don't want there to be sharp edges between this bushing and the U-shaped rod, and so what I'm going to do is sort of build some fillets into this sketch. So let me do a line right here, and another line right here. Okay, and I'll put in one of these tangent arcs. Like that. And as you can see, that doesn't end up being tangent on that other end, so I'm going to specify that it should be tangent. Like that. And I'll do the same thing over here. So I'll do another tangent arc that goes from this point up to this point. And then I'll specify that that also has to be tangent. All right. One of the things that I also want to be sure of, I have no reason why I want these to be different from each other in size. So I'm going to take those two things and set them equal. Okay. And then what you might be wondering as far as how I'm going to complete out the rest of this sketch, doing a center point arc is a good way to do that. Where I start here, say the arc is going to be based on this center point. It's going to go from here over to this other point. And because I don't trust the automatic relations it's going to set, I'm going to go in here and set these manually. Select that point and merge them. Okay, now you might say it doesn't look like this is you know, right just yet, so and I don't disagree. What I'm going to do now is specify that this point right here has to be on this surface. Okay. It looks like this whole thing might be off center a little bit, and so why don't I fix that by taking the midpoint of this line and specifying it has to be on this axis. Okay. And I think that we're basically only missing one thing at this point. We might be missing two things. One is, how wide should this whole thing be? So we need to make a dimension here to specify how wide we want all this to be. And I tell you what, we'll make it at about ½ an inch, because that's the diameter that this is going to be, so that it's kind of a size that makes sense, kind of a 1-to-1 ratio for diameter to length of the bushing. All right, and then the last thing is just how big do I want these fillets? All right, so if I go in here to one of these fillets, let's just specify it as 0.05. So we find the revolve feature under this menu right here. It's a revolved boss base, is what they call it. And we have to pick an axis that it's going to revolve around, and that's going to be this axis right here. It gives you a little preview of what that bushing might look like. And I don't think we have to change anything else. It's going to go all the way around, so I hit check. And that's going to be one of my little bushings that I use to sort of allow the assembly to move as it would, the way we assumed that it would whenever we did our hand calculation. All right, I need to save this. So let me save it as maybe larger bushing. The reason I'm going to name it that is that I'm also going to have one that has a smaller diameter to it, because I'm going to use the same method for the rocker as I do for this, and I want to be able to distinguish between the different parts. So I'm going to call that the larger bushing. Okay. Here's what I want to show you. Once you've made one of these parts, sometimes you can very easily make another one that meets all of your needs without having to reinvent the entire wheel. So what if I go in here, I can go in and I can say save as again, and it gives you some options down here. We're going to save this as a copy of this first one. I'm going to rename it. Instead of calling it larger bushing, I'm going to call it smaller bushing. Okay. And I think it'll work once I hit save. So for my smaller bushing, which starts out being the same, I need to go in here and change it to where it's going to interface properly with the rocker as opposed to the U-shaped piece. So I can do that by going in here, and one of the options it gives you up here is to edit the sketch. So that's what I want to do. And it actually works just fine to not edit anything else except for this dimension right here that specifies the diameter. It's actually specifying the radius, I guess, officially, of the rod that it interfaces with. If I double click on that, I want to change this to the radius of the rocker piece. It was a 3/8 inch diameter, so this should be 3/16. Okay, and if I hit enter, I can then hit rebuild, and you see there it has now changed the diameter of that, and nothing else needs to change, so I'm going to go ahead and leave the rest of it alone. Okay, so I'm going to now save that smaller bushing. All right, and just kind of go through the parts that we've made so far. I've made this smaller bushing. I've made the larger bushing, which is right here. It's, that one's also saved. Just to kind of, in case you didn't notice, it puts a little star up here next to the name of the part if you haven't saved it, if it's got changes that haven't been saved, and so sometimes it's good to just sort of look through that. Here's the rocker piece, and then I have a Swaybar piece. Right, I believe they are all saved and ready for the next part, which is to assemble them and then apply the simulation constraints that we need to be able to simulate the behavior of this part. So I'm going to leave that for the next video. I hope you've enjoyed this, and look for that next video if you want to see how to do this simulation and figure out how far this thing will deflect and some of the stresses that it experiences and reactions and whatnot. So I'll see you on the next one.